aren't here can know what's going on. Okay, so this is a final project that we do every year because you have to do some kind of presentation. So if you grab that project paper, it's white. I meant to copy it on yellow. Sorry, it didn't get copied on yellow. It's white. It's one you picked up as you came in. I'm just going to read through it with you. You're to break up into groups of 1 to 4. If you don't like working with people, fine. Do it by yourself. That's okay. Okay? If you want to do it in a group of up to 4, that's okay too. Okay? You may choose your group. Your job is to look at the takeaways, and you've been given all the state takeaways, right? Everybody has a packet of state takeaways that we're going to be tested on, and pick a topic that your group would like to do a review on for us. Okay? Get your topic approved quick, because once it's gone for this period, it's gone. Does that make sense? Okay, here are some examples. I've gave you some examples of things that you could pick. So for instance, if I wanted to do nuclear, I could do it's standard 1 objectives 1 through 3 and standard 2 objective 2. So that would be what I would ask to do, is those standards. If I wanted to do like spectra or bonds or chemical reactions of stoichiometry, you can sort of see everything that we've covered this year is going to be a review, and you guys are going to do the review. Okay? All right, now you need to decide. Once you decide, you're going to come up with your topic and what standards it's covering. Okay, and you got to get a topic approved. You got to come up, and I'm going to say, okay, yep, and I'm going to stamp it. I'm putting your names down and who's doing it and what topic you're covering. Once it's down in my book, nobody else can take it. Okay, I'll give you a presentation date. After we decide how many we're breaking up into, then I will say, okay, this is your date, this is your date, this is your date. Okay, you got to be ready on that date. If there's a problem with that date, you better come and see me a couple weeks before so we can adjust it. You're going to put who's in your group, their names and their phone numbers or emails or some way to get in touch with them, okay? And you're going to have your objectives. Use your imagination when you present this, okay? You'll need to make or download a video. YouTube will not run on the school or on your account, so you need to make sure that you download it and then bring it, okay? FET is also a great place to look for a simulation. Make it fun. We've had several awesome presentations throughout the years. Your group will have 30 minutes to present. If that's not enough, let me know. You can have more because we've got a smaller group. Okay, you can have more, and I've had groups take the whole period. Okay, depending on what they're doing. Maybe they want to do an activity outside with it, or they want to do something, be inventive with it, be fun. Okay, you will need to have. Remember that participation percent is the percent of your grade. Everybody in a team needs to be involved to get full points. So even if I did the presentation part of the presentation and somebody else did the demo and somebody else did this, we all need to be involved in everybody's part. Does that make sense? You're not just going to stand off to the side and say, yeah, I did that. Okay? In order to get full points. So on the front page, I have given you the rubric that you can write down who's doing what, who's their helper, what's going to be in charge. Okay, presentation, everybody should be involved in that if you have more than one person. If you're just one person, then you're the one that's involved. Okay, who's going to cover the meat? Make sure the topic is well covered. Okay, who's going to do the PowerPoint or Prezi or presentation, or you made your own video, something like that. Okay, who's going to do that? Are we all going to do that? How are we going to divide it up? You got to have a demonstration. It's got to be cleared with me. Okay, you got to have a demonstration of some sort, whether it be inside, outside, in the lab. You've got to have some kind of demonstration. Okay, you need to have a video simulation or simulation. So if you're doing a PowerPoint Prezi, or if you're making your own video up here, it needs to be a simulation down here. Does that make sense? These can't be the same thing. All right? Then you've got to have a job applicability. In other words, how can this topic in chemistry be used in a job? No, you cannot use scientist, you cannot use chemist. You've got to have a different application. Okay? All right. Whoops, let's go down. You've got to have a reference page. What things did you go look up? And it needs to have at least 5 references. It didn't pull in really good for mine. But at least 5 references, 5 places you've looked up and said, Okay, here's where I found all this stuff. Okay, and I don't care if it's book or internet. This one I don't care where you got it. Okay, but you got to have 5 places you're getting good stuff from. Okay, and you've got to have, if you've got more than one person, you've got to demonstrate teamwork. I can see that you all played well together in making this presentation, that you all did your part, that you all equally are invested in it. Okay, and then goodies are extra credit. If you can tie a goodie into your presentation and it makes sense to give it, then we can do that. And then you've got this, 100 points. This is counted as a test score. Okay, this project is counted as a test score. So this test score, you can get 110%. Okay? And since we're only doing 3 tests this term, plus your core test, this is a big part of your grade. Okay? All right. So on the grading side, turn the rubric over. This is the grading side. This is where you get your topic and standard, and you're going to fill everything in except you won't be given your presentation date till probably next week, but you need to get a stamp for your topic for being approved. Okay, again, who's in my group? But this time, this is where, right before you turn it in to me, when you do the day of your presentation, you're going to grade how they did. Now, if you don't want to put their names right here, initials are fine. Okay, or you can make a code or whatever if you don't want them to see exactly how you're grading them. But I need to know, did everybody put their full weight in? Because that was my big problem with group projects, is Joey and Carlos and Rebecca always just sit there and I did all the work, and that drove me crazy. So I want to make sure everybody's doing their full share. Okay? And this is where I'm going to grade you. I'm going to be writing down who participated, what score you're going to get, and I'll be giving those back, and that will be your grade on that test. Okay? Questions on this? So when we have some downtime today, when we go to work on daily work, so be thinking about what you want to do and who you want to have as your partner, or if you don't want a partner, that's fine. One of the most awesome ones that I had was on light waves, and he did it all by himself, and it was amazing. You know, whatever you want to do. Okay, so that's the presentation on that. We are going to go into our notes. So acid-base unit, day 1. I love acid-base. It's so much fun. It's we get to play a lot in lab, and I hope you've enjoyed doing your pH lab at home. At least had some fun. Ooh, that's acid. Ooh, that's base. Has anybody found a lot of base at home? Good. I've had some that tested everything was acid. And they came back and said, is the pH paper wrong? I'm like, no, what did you test? Oh, yep, you've tested all acids. So what have you found when you've been testing? Are most things that we eat acid or base? Acidic, they're acid, yeah, they're acidic. And what are most things that are base? What are things that you tested were base? Cleaning solutions, yeah, good job. All right, so now we've got this sort of in our head, and this was what I wanted you to figure out from doing this testing at home. What things are acid, what things are base, how do we use them? Okay, so in our notes, we've got to learn some words, some vocabulary. The first words that we're going to be using is hydronium and hydroxide ions. A hydronium ion is an H3O+, and I'm going to change that right now because I don't like. Okay, H3O+. Sometimes you also see it as H+. Okay, the hydroxide ion, though, is always the same. It's OH-. Okay, so you'll hear me talk about a bullseye. When I talk about the different kind of theories that have to do with acid bases, I think of it like a bullseye. Okay, there are basically 3 theories. You are going to be responsible for the 2 most inner ones. If you go on to CE or you go on to AP, you're going to be talking about the outer one, which is Lewis. He had to do with the Lewis dots. Remember that? Way back when? He had more of a vague idea of what acids are. He talked about the weakest acids. So if you go on to the upper divisions, we talk about the weaker acids. But for us in Gen Chem, we're going to talk about the stronger acids and the more common weak acids. Okay? So we're going to talk about Arrhenius, and he's a center. Okay? He defines acids as things that give H+. And he defines bases as things that give OH-. Well, that's pretty easy. If something has an H+, it's probably going to be an acid. If something has an OH-, it's probably going to be base, right? Pretty easy. All right, so, what's going on here? Well, I've got two waters reacting, and I get a hydronium ion and a hydroxide ion. What? You're telling me that water is acid and basic? Well, water is what we call amphoteric. I always get this wrong. Photeric. If I'm off on that, that's supposed to be a, let me do that again. P-H-O, amphoteric, I think. I'm always horrible spelling. Amphoteric means it can act like an acid or a base. It's one of those friends that, you know, is sort of flippy-floppy. You know, if they're with this group, then they act all, yeah! But if they're this group, they're all, you know, they just sort of change, okay? They can act either way. It depends on who they're with. So if water is with an acid, it'll act like a base. But if water is with a base, it will act like an acid. So it's sort of just there. Well, if water is with itself, then one of them acts like an acid and one of them acts like a base. Okay? We can write it like this, or we can write it like this. Two strands of chemist thought. Okay? Some of them are like, oh no, you've got to show everything. And others say, no, you just got to show what's reacting, what's happening. Okay? So let's move on. So we're looking at this, and we're saying, okay, what's an acid and which one's the base? Anybody tell me which one's the acid or which one's the base? Yes? HCl is the acid. How did you tell that? Ah, the H+. So that told you it was acid. Okay, I'm going to ask somebody else for the other one. What's the next one down? Who knows? What? Base. How did you tell? The OH. Oh, it's a base. Well, I didn't have to wait that long. I could have come over here and said, oh, guess what? That's an acid. And oh, look, that's a base. Right? Okay? So pretty easy to identify right now at Arrhenius level. Yeah, pretty easy. Okay? Now we go to Bronsted-Lowry. Okay, now this gets a little bit more hairy. How do I know which one of those was the acid and which one was the base? On the reactant side, how do I tell which was the acid and which was the base? Ooh. This is what comes into play here. This one, going from this side to here, did what? What happened to it? It gained an H+, right? What happened to this one as it went from here to here? It lost an H+. Ooh, can anybody guess what the definition for an acid and a base is in Bronsted-Lowry? It has to do with, and if it's H+, that means it's lost its electron. What's left of the hydrogen? Think back down to our neutrons, protons, electrons. What's left in a hydrogen if I've taken away the electron? Not a neutron. Oh, proton, the only thing left. Okay, so I have a proton. So definition here of an acid is a proton donor. And of a base, what do you think? Proton acceptor. Whoops, I can spell really. Not really. Okay, so using those two things, which one's going to be my acid up above? Which one of the reactants? The H2O. So I'm going to take here and I'm going to say, okay, my H2O is acting as my acid. Okay, and my NH3 then has to be acting as my base. Now, here's the tricky thing. Did you notice this? It goes both ways. So because it goes both ways, which one would act as an acid going backwards? Which one would be able to give a hydrogen going backwards? The NH4 would act as an acid. So we call it a conjugate acid, meaning it's the acid for the backwards reaction. So what do you think OH is going to be called? Conjugate base. Good. Now, see how we've hooked them together with the lost and the gained? Those are known as either conjugate acid pairs or conjugate base pairs. And we always talk about the reactant side when we're doing that. Okay, so my conjugate acid pair would be my H2O and my OH minus. My conjugate base pair would be my NH3 and my NH4 plus. Okay, we're going to do more with that in just a second. We okay? All right, moving on, maybe. Here we go. So let's identify this one. Who thinks they know which one's the acid? Right away. Which one will be the acid? Which one gave up a hydrogen? H2O gained it to become H3O, so it accepted it. So this one lost, right? Okay, so this one would be my acid, right? All right, so what does that make H2O? Base. Remember, H2O is amphoteric, meaning it can go either way, whoever it's with. Okay, it sort of balances everybody out, chills them out. All right, so that means going backwards. If I'm going backwards, which one's going to be my acid? Going backwards this way. This one, because it has a hydrogen. This one doesn't even have a hydrogen to give, right? So this one's going to be my conjugate acid. And that means ClO2 minus is what? My conjugate base. Okay, let's connect pairs. What is going to be my acid conjugate pair? Those two are going to be the acid conjugate pair. What are my base conjugate pair going to be? There you go. Pretty easy, right? We okay? All right. Now, there's some errors on your notes, so make sure you're fixing that as you go. I think some of the subscripts or the charges are wrong on some of them as we go through. So watch that. Okay, so I'm going to give you a second. See if you can do this one by yourself. See if you can do this one all by yourself. I'm going to pause the video. Okay, I'm going to bring you back together. I'm going to use the back row back there. And I'm going to have you tell me one thing to label on here. Malachi, I'm going to start with you. Tell me one thing to label. What would be the acid? Which one gave up a hydrogen? Or what would be a base? HCl would be the acid. Okay. Okay. Good. Okay. Yes. Okay. Good. Give me a pair. Give me the acid pair or the base pair. Where we hooked them together. What two things go together? The acid and its conjugate base. Okay, so that would be one. Good. What's another pair? Good. All right, fairly easy, right? Not real hard, I'm hoping. Okay, so you just got to identify which one gave up the hydrogen. Oh, this one did from the side to side. So as I'm looking at it, as I'm going from side to side, this one lost a hydrogen, right? That's a pair. So if it lost a hydrogen on from one side to the other side, that becomes a pair. Okay, if I gained it like this one did, from this side to this side, that becomes a pair. Okay? All right, let's move forward. So let's predict what these guys will become. Now I don't even have the full equation. I'm just being given these acids and asked to find the conjugate base. What happened from an acid to base? What happened? It lost a hydrogen. So going from an acid to a base from one side to the other, it lost a hydrogen. So let's go this side. This becomes what? Who's brave? HF, done. Okay, what does this become? HSO4, but I lost a positive here. Negative. Okay, what about the HNO3? NO3, negative, good. What about H2CO3? HCO3, negative. It wouldn't be negative because it started with a positive. Good catch though. All right, so if I'm already negative and I take one more, I'm going to become more negative, right? If I'm really positive and I take one away, then I'll become less positive. All right, let's look at this one. We're going to predict the acids. What was an acid? What happened? If I have a base and I'm becoming an acid, what am I doing? I'm adding, what am I adding? H. Okay, so what does NH3 become? NH4 plus, good, because I'm adding a positive. What about CH3COO? That's another thing for acetate. Okay, you can write this one of two ways. We can rewrite this as C2H3O2 minus. That's how we've been seeing it. This is just the organic way. So if you go on and do organic chemistry here, or you go on to do CE chemistry, you'll see organic. So this is just the same thing. These two are the same. So now what do I do? Now I add the H. So I can write it like this, and it would just be positive, or I could write it, the organic way would be like this. Okay? So it is an organic molecule. It's just vinegar. Okay? It's what we make vinegar out of. Vinegar is a very, very small dilute amount of this. Okay? What about PO4 minus? -2. Good. Everybody see how that works? Okay, everybody do the last one by yourself, and then we're going to put it up and see if you got it right. Don't look up until you've got it. How'd you do? Got it? Yeah. Pretty easy. Okay, so how do I know if it's a strong acid or a strong base? Well, a key is the arrows. If it's a one-way arrow, it's going to be a strong. Okay, if it's a one-way arrow, it is strong. If it has a double-sided arrow, you've got a weak acid. Okay, but what if I'm the one writing the equation? We'll get there in just a second. What happens with strong acids is they completely separate. Okay, completely ionized, 100%. They are split. Okay, this is not very nice divorce. They're totally split. Okay, this one on the other hand is sort of like a more amicable divorce, and they're still talking to each other and getting along and doing stuff together. So this one is usually 1 to 5% split, which isn't very much. They still do a lot of stuff together. Okay, so let's go on to the next part. Strength of bases, same thing. We're looking at the arrow, and if it's one way, it's 100%. If it's not, it's usually 1 to 5%. Okay, so how to identify them? I like to use the periodic table here. My bases are blue, and this is the pattern they go in for my strong bases. Well, what is in that area? Well, let's look and see. That is lithium, sodium, potassium, and then we slide over to calcium, strontium, and barium. Well, remember bases are what? OH, right? So that would mean lithium hydroxide, sodium hydroxide. For its first column is what, +1, and hydroxide's a -1, right? Second column is what charge? +2, so I need 2 hydroxides, so it becomes calcium hydroxide, don't forget your parentheses, and barium hydroxide. So these are 6 strong bases. Okay? Now acids are usually, so when you were doing your pH strips, bases were usually dark blue. Okay? Acids are usually pink. And we have a difference in acids because acids could be just regular acids, binary acids, which means just hydrogen and one other thing, or they can be oxyacids, which means hydrogen and a polyatomic. Okay? So we have those 3 that are oxyacids. And the oxyacids go with what's there, but they add oxygen to it. So NO3, SO4, and ClO4. What do you notice as a trend there? Three oxygens, 4, right? 3, 4, 4. Okay, so I've got HNO3 as an oxyacid, H2SO4 as an oxyacid, and HClO4 as an oxyacid. Nitric acid, sulfuric acid, perchloric acid. Then I also get binary acids. And the binary acids start with chlorine and go down. So I'm going to do chlorine in Cl, dark here, Cl, Br, and iodine. So down here I'm going to get HCl, HBr, and HI are also strong acids, meaning they'll 100% dissociate. These are binary acids. These ones are the ones that start with hydro, hydrochloric, hydrobromic, hydroiodic. By the way, high, very nice acid, says hi to you, and then eat you alive. Okay? So we've got 3 oxyacids that are strong, 3 binary acids that are strong. Okay? Now, you've also been given a chart with these on them, with their names. Okay? Right? I mean, you were hurrying, writing them all down. But I wanted you to see where they were on the periodic table and how to remember them. I call this over here swoop and down. The swoop is the oxyacids, and the down is the binary acids. Okay? Over here, I call this area over here, where the bases are, the tetras, because it's sort of like a tetras pattern. Okay, yes, it has one extra on both sides, but that's okay. I think I don't know where, oh, you tell you got there. Okay, so you've got the list of them, how to name them. This is back to being able to name things. Oh no, we went through that already. I thought we were done. Nope, it comes back and haunts you and haunts you and haunts you. Remember, if it's just one hydrogen with one other thing, we always do hydroic and acid with a base name. If it is a polyatomic, the hydrogen just tells me acid. I take whatever the polyatomic was. Remember Thanksgiving dinner? If it was 8, it went ic. If it was ite for the polyatomic, then it went OS. We're going to get in a fight, right? So it became OS. All right, going on. That's the end of the lecture today. So you're going to be working on your assignment number 1, okay? And coming and telling me what you want to do with your project, okay? Questions? All right, I'm going to stop